Lipids include fats, which provide energy storage. Lipids have a common structure in that they are nonpolar, meaning that they are water insoluble, so they do not mix well with water. There are 4 types of lipids: triglycerides, which include the fats that we eat, ketone bodies, phospholipids, and steroids. For triglycerides, the structure consists of saturated or unsaturated fatty acids. The fatty acid that is saturated is a long chain of carbon molecules that are bonded with a single bond. The reason why it's saturated is because it's saturated or has the maximum amount of hydrogen atoms attached because of the single bond. Unsaturated fatty acids, if you look, you can see the difference between the unsaturated versus the saturated. There are double bonds in the unsaturated fatty acid, meaning that you don't have the maximum amount of hydrogen, or you're not saturated with hydrogen. And this is why it's called unsaturated. If we want to talk about the nutritious value of saturated versus unsaturated fatty acids, the saturated fats are unhealthy and they tend to be more solid, such as butter. These saturated fats tend to stack better and therefore not break down as much. Unsaturated fatty acids tend to be more healthy in a liquid format, such as oil, for example, olive oil, and also include omega-3 fatty acids, for example, found in fish. These tend to break down easier and be used better by your body. The most unhealthy type of fat is called trans fat, and that is a specific type of saturated fat. If we look at a trans fat, what you'll notice is that it is a trans bond right here that is formed by artificially adding a hydrogen to the opposite or trans side. So if you look here, you can see the 2 hydrogen atoms. And so this is man-made. And the reason why we might make this trans fat, even though it's unhealthy, is that it is more stable, so it has a longer shelf life, and maybe it tastes better. So if you were to look at a nutrition label, it's important to note the amount of fat. And importantly, when you look at the fat, you will see saturated and trans fat. And both of those, remember, are the unhealthy fats, which is why it's required by the FDA, the Food and Drug Administration, to report both of these types of fat. So to be healthy, you do not want to see a high amount of fat, specifically the saturated and the trans. A clinical application would be to relate this to cholesterol and atherosclerosis. Part of the reason why saturated and trans fats are unhealthy is because they can contribute to both of these diseases. Now look at the overall structure of a triglyceride. It consists of a glycerol, which is where the word glyceride comes from, and 3 fatty acids. So the 3 fatty acids is where the word tri comes from, and that gives you a triglyceride. And remember, we said that lipids are a great source of storage energy. And the reason is because in the bonds of all the carbons and hydrogens in the fatty acids, that is where the energy is stored. Next, we have ketone bodies. They are free fatty acids from adipose tissue or fat tissue. And importantly, they are only an emergency source of energy. In other words, if you are healthy and in a normal BMI range, you should not have any ketone bodies present in your system. And we will discuss more about why later. A clinical application is thinking about the relationship between ketonuria, which is detecting ketones in urine, and weight loss. In other words, why would you test for ketone bodies in your urine, and if they are detected, what could that indicate? Next, we have phospholipids. Phospholipids consist of a water-soluble or hydrophilic head, hydro meaning water and phil meaning love, so the head actually mixes with water, and water insoluble or hydrophobic tail, phobic meaning phobia or fear of. The reason why phospholipids have these structures is because they are found in the cell membrane, and they help you make a phospholipid bilayer. So notice the heads are on the outside facing the water, and the heads are also on the inside of the cell facing, again, water, while the tails face each other in the membrane and therefore are away from the water. So that's why it's important to have the bilayer, heads on the outside and inside, and tails hiding in the middle. Last, we have steroids. The structure of steroids is that there are carbon rings. So you'll see here 4 carbon rings, and then you'll see variations within the rings and the groups off of the rings. The functions vary a lot for steroids. For example, they're found in cell membrane. They serve as many hormones, such as cortisol, which is a stress hormone, and they are reproductive hormones such as testosterone and estrogen and progesterone. And that concludes our major categories of